Welcome to lesson number 4, Operations with Functions, Part 3. So up to this point we've looked at operations with functions when we're adding and subtracting, when we're multiplying, and now we're going to look at when we are dividing. So we are investigating the quotients of two functions. Now in this following example I'm given two functions, f of x and g of x, and they are defined for all real numbers. Now I have both of my graphs on my grid here. My first one, I'm given a parabola, and that's y is equal to f of x. And I'm also given a linear equation, and that is y is g of x. Y is equal to g of x. Now the next thing I need to do is fill in my table of values below, right here. And let's finish the table for all my values of f of x first. So when f of x is equal to 3, I'm going to have a value at 6, right? I follow that value up to 6. When I am at 0, or sorry, when I'm at x is equal to 2, I'll be at 0. And when I'm at 1, I'll be at negative 4. And it looks like I have a minimum value of negative 6. And at negative 1 and negative 6 as well, negative 2 at negative 4, and then I follow that pattern and I go back up. Now for g of x, remember this is a linear equation, so it's not going to follow the exact same structure or exact same pattern that we followed over here, but if I look at where x is equal to 3, where x is equal to 3, looks like I am at 1, then I go down to 0, and then I go down to negative 1, negative 2, negative 3, negative 4, negative 5, and negative 6. Now the next thing we want to do is we want to figure out what the function is going to be when we combine these functions. So function f divided by function g. So they've done the first one for us. It's 14 divided by 2, and so our point on the graph will fall at x. When x is 4, it'll fall at y is equal to 7. Okay, so the next one is going to be function f, which is 6, divided by g of x, which is 1. We're just going to get 6. 0 divided by 0. Well, we're going to have a divided by 0 error, so that's going to be an indeterminate. Negative 4 divided by negative 1. Negative 4 divided by negative 1, we're going to get 4. Negative 6 divided by negative 2, we're going to get 3. Negative 6 divided by negative 3, we're going to get 2. Negative 4 divided by negative 4, we'll get 1. 0 divided by negative 5, we get 0. And 6 divided by negative 6, we are going to get negative 1. Now explain why the domain, let's answer this next question now. Well actually, before we do, we'll just review quickly what we did here. We were able to, from the graph, determine what these values are for my function of x and my function g of x. The next thing we want to do was to combine these two functions, function f divided by function g, and what we're doing here is we're combining our y values as quotients. So I divided my 6 by my 1 to get my value of 6 for my new function f of g of x, f divided by g of x. So what we're going to do now is explain what the domain of the function is. Alright, so explain why the domain of the function f divided by g of x is not x is an element of all real numbers. Well, if we look at this point here on our graph, when x is equal to 2 for f of g of x. Alright, so if we look at this section, we have an indeterminate. So if you divide any number by 0, what happens? You are going to get an answer that is undefined, what is known as an indeterminate. And because of that, that means that there must be some restrictions on our equations on our functions when we combine them. And so the function f of g of x is actually undefined at the point where x is equal to 0. Is undefined when, and more specifically, when g of x is equal to 0. So an example is when x is equal to 2. So when x is equals 2, we actually can't have any data there. So our domain ends up being, so if we're looking at our domain here, our domain ends up being x can't equal 2, but x actually is an element of real numbers as long as x cannot and does not equal 2. Alright, so the next thing we need to do is sketch the graph of f of g of x, f divided by g of x, and then show the domain restriction by drawing an open circle on the graph. Alright, so let's do that now. In order to draw our new graph, what we need to do is look at our original data points. So if I had x is at 4, so x is at 4 here, but we're actually going to be at 7 for my new function. So when I'm at 4, I'm going to be up here at 7. When I'm at 3, I'll be down here at 6. 3, 6. When I'm at 2, okay, so this is where my graph is actually going to be undefined. So at 2, and it looks like we're going to follow a linear equation here again, and so we're going to skip that point for now just to see where it would fall on the rest of my lines. So let's see when I'm at 1. When I'm at 1, I'm going to be down here at 4. When I am at 0, it's going to fall at 3. And looks like we have a slope of 1 here. And so negative 1 will be at 2. We're going to follow linear regression like this. Now, what we wanted to do, though, was show the domain restriction by drawing an open circle on the graph. And so to show our domain restriction, we would actually draw the open circle there. And that shows us the value for which x cannot equal. Alright, so here's our new graph, or our new function. Okay, part D. The functions f and g above are f of x is equal to x squared plus x minus 6, and g of x is equal to x minus 2. Write and simplify an expression for the function f of g of x and including the domain restriction. Okay, so here's my first function and my second function. Now, if I had f divided by g of x, what we're actually doing is we're dividing this first function by the second one, just like we did before when we were adding them or multiplying them, finding the product. We're going to begin with our quotient, so x squared plus x minus 6 divided by x minus 2. Now, this is when we get into working with some of the concepts we were working in pre-calculus 11. And so here we are going to be working with rational equations. This is what we have here. And the first thing we need to do to solve this problem is to factor this. So x squared plus x minus 6, we're going to get x plus 3, x minus 2. And we're going to divide that by x minus 2, and we can cancel out what we have on the bottom. And so our simplified form of this equation is going to be x plus 3. And if we go back up to our graph, f divided by g of x is equal to x plus 3. Well, let's look at where we start in our graph. We have our value of b at 3, which is good, and we increase by 1 and over by 1 each time, rise and run of 1. So perfect, that's what our equation is telling us. But remember, there is a restriction on the variable, and remember that this restriction comes from g of x down here. And remember, we can't divide by 0, so if I were to insert x is equal to 2 into this above equation, we are going to get 2 subtract 2 on the bottom, which is 0, and we'll have a divide by 0 error in the end. And so we also need to state our restriction: x cannot equal 2. All right, so part C, evaluate f divided by g of x, and x is -6 in this case. And so remember, our simplified equation was x plus 3, and so what we need to do here is insert our value -6 for our value of x, so -6 plus 3, and we will get a solution of -3. Okay, let's move on to the next problem here. All right, it's good to read this too. In the first investigation, the graph f divided by g of x cannot include the point 2 and 5. All right, so that's where we drew our open hole for our domain restriction. All right, so there was a domain restriction at x can't equal 2. And so this results in a hole in the graph represented by an open circle. And so that hole is what we call the point of discontinuity. And we will talk about that more when we talk about rational functions. All right, so in each case, write and simplify where possible an expression for f divided by g of x, and then include any domain restrictions. All right, so if I have f divided by g of x, that means I'm going to have 2x plus 5, which is my function f, and I'll divide that by my function g here. So this is my function f and my function g, and that's x plus 5. Now, we can't really simplify this anymore, so this is as simplified as we're going to get, but we do have to state the restriction. And in this case, if I have x plus 5, then all you do is take this part of your equation, set it equal to 0, and solve for x, and we are going to get x can't equal -5. Another thing you can do is just look at the sign that you have in front of your integer, and it's just going to be the opposite sign for your value of x. So f divided by g of x, and in this case we're going to have x squared minus 2x minus 35 for my function f, and my function g is x minus 7. Well, we are going to need to factor this. So -35, two integers that multiply give you -35, and add to give you -2 are going to be -7 and +5. And perfect. I have -7 on the bottom, so we will cancel that out. And our simplified form of this equation is x plus 5. Remember to state your restriction. In this case, x can't equal +7. And part C. Remember, we are solving for f of g of x. And x minus 2 divided by x squared minus 5x plus 6. And we are again going to have to simplify this. So x minus 2 divided by two integers that multiply give you +6, and add to give you -5. We're going to get x minus 2 and x minus 3. Cancel those out, and we are left with 1 over x minus 3 with, in this case, two restrictions. Can you guess what they'll be? X can't equal +2 or +3. Okay, so consider the functions f of x is equal to 2x squared minus 13x minus 7, and g of x is equal to 2x plus 1. State the domains of f and of g. Well, first of all, it looks like we'll have x are elements of real numbers. However, we will have a restriction, but it's not really asking for the restriction of our function f divided by g. It's only looking for the domains of these two of these two functions separately. Okay, so if I look at these domains of 2x squared minus 13x minus 7, that's going to be x is an element of real numbers. But if I also look at the function 2x plus 1, it's going to be the same thing. X is an element of real numbers. Now we want to write the expression in simplest form for f divided by g of x, and then we'll state the domain again. And there is where we'll have some restrictions. Okay, so if I'm looking for f divided by g of x, I'm going to be using my function f first, so 2x squared minus 13x minus 7, and I'll have to divide that by 2x plus 1. Okay, well, if I look at my 2x squared minus 13x minus 7, this is something where I will need to use factoring in order to solve. So I'm going to bring it over here to factor it. 2x squared minus 13x minus 7 is going to be, this is where we have to use our process of decomposition. So multiply 2 by negative 7, you'll get negative 14. Right? They need to multiply to give you negative 14 and add to give you negative 13. So we're going to use negative 14 and positive 1. So negative 14x plus x minus 7. And if I factor out the 2x here, I'll get 2x. That's 2x squared, sorry. 2x x minus 7. And I'll have to factor out d1 in this case, plus 1 divided by x minus 7. And so my two terms, once I combine these, I use my process of grouping, I get 2x plus 1 times x minus 7. All right, so we're going to put that over here, and so I have 2x plus 1 times x minus 7 divided by 2x plus 1, and there we have some canceling out, and we're left with x minus 7. And remember, we need to state our restrictions. 2x plus 1, if we solve for 0, we set 2x plus 1 equal to 0. Alright, so I'll do that in a different color here. So if this is for my restriction, 2x plus 1 is equal to 0. If we solve for 0, we are going to get negative 1 on this side and 2x over here. If we divide by 2, x is going to be negative 1/2. Okay, so the restriction on our variable is going to be x cannot equal negative 1/2. And such that x is an element of real numbers. Don't forget that. Now explain two different ways to evaluate f of g, f divided by g, 3, and calculate. Now one thing we can do is we'll use the formula for this, f divided by g of x, and then replace x with 3. And so if we were doing that, so number 1, use formula for f divided by g of 3. And so our simplified formula, remember, was x minus 7, and so all we would have to do is insert and substitute 3 for x, and so we're going to get 3 minus 7 is equal to negative 4. So that would be your answer. Another thing we could do is evaluate the original equation, so using f of x and g of x, and then substitute x with 3. And so what we would do is we'd use these original equations and we would put 3 into original equations and then divide, and we're going to get the same answer of negative 4, which I'm not going to do because it takes too long. Okay, let's consider the following. Consider the functions f of x is equal to 2x divided by x minus 1 and g of x is equal to x divided by x minus 3. Now this is a little different because what we're used to seeing are two equations where whereby there's no terms on the bottom on my denominator, So this will change things just a little bit. So state the domains for functions f and g. Well, for function f, well, if we look at it right away, there's going to be a restriction. So x cannot equal, in this case, positive 1, such that x is an element of real numbers. And for my domain at g, again, there's going to be a restriction down here. So x cannot equal positive 3 such that x is an element of real numbers. Now what we want to do is evaluate 3 multiplied by f times g, and then substitute all our values of x by 2. So what this is going to look like is we have our value of 3 in front of our functions, and so 3, 2, and remember we're substituting the value of 2 for my values of x, so 2 divided by 2 minus 1, and then so this is my function f of x right here. And now I'm going to put my function g of x down here, and my function g of x was x divided by x minus 3, and we're substituting my value of 2 in for x, so that's going to be 2 divided by 2 minus 3. And what we'll be left with is 3 times 2 times 2 is 4, 2 minus 1 is 1, so 4 divided by 1 is just 4. And then I'll have 2 minus 3 is negative 1. That's going to be negative 2. Alright, so 3 times 4 is 12, times negative 2 is negative 24. And that's our final answer. Now write an expression in simplest form for f plus g of x, and then state any restrictions on x. So what we're doing is we're going f plus g of x. And I know that my function f was 2x, x minus 1, plus g of x, which is x divided by x minus 3. Now, this may look a little familiar, right? We are again working with rational equations. And so what we need to do with this rational equation is, well, you'll have to recall from last year, but last semester. But what we're doing is we're looking for a common denominator between these two, right? It's basically a fraction that we have to find a common denominator in order to find a sum. And so in this case, our common denominator will be x minus 1, x minus 3. And so in order to get x minus 3 on this side, I have to multiply x minus 3. So that'll be 2x times x minus 3 plus x times x minus 1 to find that common denominator of x minus 1 times x minus 3. And now we need to expand, and I'm going to get 2x squared minus 6x plus x squared minus x all over x minus 1, x minus 3. And this here we can simplify. I have 2x squared plus x squared is 3x squared. 3x squared, 6x and x, negative 7x, all over x minus 1 and x minus 3. And I can take the x out of here, so if I simplify that, that's going to be x, 3x minus 7 over x minus 1 and x minus 3. And x cannot equal positive 1 or positive 3. Okay, so what I want you to do is attempt question D on your own. This is something you can do because you did exactly this last year, except for you weren't working with functions or relations. You were just working with an equation. But you are going to make this equation yourself, and this is something you can do.